Hi, I am Marcel Bossard, the executive producer and a former lead programmer of Microsoft Flight Simulator. And today I am here with you to talk about the beauty and the realism of Flight Simulator made with Azure. So we've been said that the wheel for a new generation of flight simulators has always been there at Xbox Game Studios, but that the step from the previous opus to a new one had to be significant enough. A glimpse of what could be this next generation of flight sim came to the team when we worked on HoloTour with some photogrammetry data. And at this time we thought, what if? What if we could use this tech as a base? What if we could use Azure Big Mac as a base for Microsoft Flight Simulator? And with this, Flight Simulator would have every pikes, every oceans, every rivers, valleys, mountains, and even representation of built structures, and this all around the world. That said, for a flight simulator, this base was not sufficient. When we talked with Jörg Neumann from Microsoft, we had a dream of what should be the next generation of flight simulator. And on this dream, we also included a true management of the plane's dynamics. And it means all the forces and a true model of the air masses and the weather. But also buildings, towns, and roads so accurate that we would allow flying with visual flight rules like in real life. All simmers would fly in the same airspace. And with the real-time air traffic and using the true navigation data. And on top of that, we would like the simulations to provide also all the services that can smooth the experience. So if we put that all together, we can resume these ideas by this. So we had to create the most realistic Earth digital twin ever seen from the air, with its geography, its sky, air model and weather, but also with its real-time activities. We had to distribute all these data, and we had also to gather all the pilots in one unified world, and also to deliver all the services they needed. So as you can see, plenty of challenges here. And yes, yet this is with this concept that we've decided to take off for a prototype. And this presentation is about where we landed. So let's translate each of the last slide's challenges into technology. So first, we need computing power for recreating the world, for collecting real-time data. But once computed, we also need to store and deliver these data. And we have to create a multiplayer service that mixes all pilots into one unified world. And finally, we also needed to set up and to use services for account management, to have an in-game store also, to have some analytics, the text-to-speech situation, and even the project management. So as you will see in these next slides, the designs we have created and the solutions we have chosen are built upon Azure technologies. So as said earlier in this presentation, the sim is initially based on Azure Big Map. But as you can imagine, a flight simulator is not the initial purpose of a map service. So in order to create the experience, we had to bring what we call augmentations. So these augmentations start with the use of some other data sources, but also it means also to bring some photo treatments, some data treatments. It's also use some new technology like deep learning. And for each of these processes, we had to do some research. We had to create some prototypes. And those prototypes were needing some computation power in a very large scale, because as my dear friend Lionel says, the world is big. And we finally figured out that the best way of doing so was by using Azure. So I would like to show you some samples of one of the processes we've designed and used to recreate the world. So this first example illustrates two computer vision processes for cloud removal and corrections to erase discrepancies from the aerial pictures. So in order to add trees and vegetation, we started with the definition of the local biomes. We did some vegetation detection. And by mixing these two layers of information, we were able to populate the landscape with the right species at the right place. Azure Big Map provides city in 3D using photogrammetry, but we had to recreate buildings where it was missing. So thanks to Azure, we can temporarily use computation resources to detect and recreate the buildings by finding the footprints, the height, the roof color and types, and merge all these information with local specificities. Like for trees and the vegetation, this process is using machine learning. So by running all these processes like the one we've shown, and on top of that adding some others, and with the use of our engine, we finally succeeded to capture the beauty of the world, whatever the place you want to fly over. So as you can imagine, we have even more processes running. The text and the algorithms are constantly changing to bring even more realism. So the beauty of this system is that the design can be as creative as it wants to be. We are no longer stuck by an hardware infrastructure. So we can increase, modify, decrease the usage depending on the new needs. So the world of flight simulator is not static, right? It's not stiff. It has to be hydrated by real-time data. So the first real-time data we're collecting is the weather. So it might be the most important and the more impressive real-time data we've got in the simulations. But we're also using updated professional navigation data and real-time air traffic to bring life into the simulation. That said, we also intend to bring more real-time data in the future. And for each of these data, each of these processes, we add some Azure setup. And these setups, these services, are ingesting and updating on their own pacing the data we are collecting from our providers. So as you can imagine, real-time weather and data like data for navigation does not update with the same frequencies. So thanks to Azure scalability, each service has its own setup to use the computation power for the amount of times they need. So once we've got these data computed, once we've got everything's done, we need to store and then to distribute the data. So we are using Azure in order to do so. The data we are generating are sized differently, so we are using the scalability of Azure to adapt our storage to our needs. These data are distributed worldwide, thanks to Azure CDNs, helping us to guarantee the quality of our services wherever users are on the planet. Azure also provides all the monitoring tools and alert systems that help us to check the sanity of our services. So I'd like to illustrate this presentation with a first use case. This first use case is based on our multiplayer service. So what was the goal here? It was to have one unified world for the multiplayer. So all the simmers from the globe could share the same airspace. So what does it mean? It means that we need persistency in experience to travel, for instance, from New York to Beijing completely seamlessly. We also wanted to have no visible instance. So the user, they won't have to select a server, and they won't be separated the one from the others. So we had to do some split of the world. So we had to dynamically share the planet depending on the location of the user. Well, and this is how we set up our scalable service. So as I said, the main idea here is to dynamically split the Earth depending on the number of users. So we are using on one end Microsoft Azure services, all administrated by a toolset done with Kubernetes. And on the other side, we're also using Azure PlayFab multiplayer services. I will talk about PlayFab later on this presentation. So on the low part of these charts, you will find the clients. Each client informs the dispatcher where in the virtual world the simmer is flying. And this goes through a load balancer. And in return, the dispatcher gives back the server the client can talk to. On the upper left corner, the server's coordinator is based to check if the user are correctly distributed all around the world. And this coordinator manages the number of servers used for the experience on PlayFab. If an area of the world gets too loaded, then the server's coordinator will split this area and create new server on PlayFab and informing the client dispatcher through a cache. And when possible, the coordinator does the opposite by merging two servers into one. So by doing so, Simmer can fly permanently all around the globe with the guarantee that he can have all the other closest pilots flying very next to him. So Flight Sim is a game as a service. So of course, our goal here was to smooth the experience as much as possible, so Simmer won't have to struggle anymore to enjoy the diversity of virtual flights. So ideally, what do we want here? What do we want? We want a unified account management space on Xbox Live. So whatever the platform you're using, including Microsoft Store, Steam, or Xbox. We also wanted to create an in-game store, so the users won't have to dig into the net to find their add-ons, but also to allow third parties, the one that creates these contents, to allow them to export their content and to sell their content on the store. We also needed some analytics. These analytics are here to help us to understand what are the simmers needs, what are their usage. And as I said previously, we also wanted to use the multiplayer layer. So as a matter of fact, Azure PlayFab was delivering and fully filled all these needs. So that's why Azure PlayFab today is extensively used for live operation. Oh, and I could not forget Azure DevOps in this presentation, because this is the very tool we are using. I mean, all the members of the team is using on a daily basis. And on top of that, with having partners all around the planet, Azure DevOps is really a core tool for the development that helps us to synchronize, to list, to task, and to monitor every single build we are delivering. So during this presentation, Azure could have been seen like a mandatory choice for the team. In fact, it was not. The choices of our tool has always been the result of a process for selecting the best one. So this next slide is a use case presented by Aurélien Peters, our audio director at Asobo, and he will explain you what was the process that led us to choose Azure for TTS.
Hello everyone, I'm Aurélien, and I'm going to talk about how we used Azure services for ATC communication. Air traffic control, or ATC, is a key feature in Flight Simulator. Pilots communicate with control towers, and the information they gather from this exchange are crucial. Are you able to land? On which runway do you land? What's the weather? And so on. It's a huge part of the flight experience, and it's an expected feature by simmers. First, let's listen to a sample of an original ATC communication to understand more clearly what we are talking about.
Etihad 102 Heavy, clear to Abu Dhabi. Happy 3 departure, fly runway heading until the Kennedy 1.5 DME, and then a right turn heading 100.
So you can hear a lot of radio signal degradation and a very neutral tone. ATC is usually sounding like data over human voices. It's something important to understand since it influenced the way we worked. So what were the challenges of simulating ATC? The major problem is the amount of VO needed. We are talking about more than 50K airports, thousands of aircraft, and the combination of these data in different sentences. The control tower needs to provide you a lot of details, and you will rarely get the same sentence twice, and with different speakers on top of that. So it means a lot of VO, and the question was, how do we handle so much VO for Flight Simulator? We considered different solutions following our researches and our legacy from FSX. The first one was recording all the VO, but the amount of VO needed to cover all the ATC lines possibilities would mean something like 5 million lines, so it was a no-go. Then we had the concatenated options. They were really interesting and providing a good voice tone, but the main problem was flexibility. When a new airport or a new plane is added, you need to go back to the recording studio. There's also a lot of edits to be made on the audio with markers and so on. So we were lacking flexibility, and the voice prosody wasn't always perfect due to concatenation. And the last but not least was cloud text-to-speech. Obviously, Cloud TTS was the most flexible solution, but we also wanted an improvement on the voice quality and prosody. Many cloud providers offer text-to-speech services, and Azure were doing it too, and also what they call custom voice, a technology allowing the user to create their own TTS voice by providing voice samples. It was quite unique at the time, and we were really excited by it. So we did some testings with our own recordings, and the results were very encouraging with only like 500 lines of VO samples. As we don't convey emotion or different emotions with ATC, the technology was very appropriate. We recorded those samples with a consistent speed and a very natural tone, and the more voice we provided, the better the quality was, as custom voice is based on machine learning. On top of that, we also processed VO with a real-time audio distortion to simulate radio signal degradation, and the result was quite close to an ATC communication. Now here's a quick video of our in-game implementation of ATC communication, where you can hear custom voice and real-time audio processing.
Zurich Center Cessna Alpha Sierra X-Ray Golf Sierra Alpha 7 miles west of Locarno. Request IACMAR to Malpensa, ready to copy.
Cessna Alpha Sierra X-Ray Golf Sierra Alpha is cleared to Malpensa Airport as filed. Squawk 2527.
Cessna Alpha Sierra X-Ray Golf Sierra Alpha cleared to Malpensa Airport as filed. Squawk 2527.
Cessna Golf Sierra Alpha readback correct. Radar contact 8,400 feet. QNH29er decimal 9er, 2 turn left heading 175, resume on navigation climb and maintain 12,000 feet.
Now let's talk about the cost and different TTS flavors Azure is offering. More than the custom voice, Azure supports other text-to-speech technologies, and for Flight Simulator, we went for standard and custom voice. In the previous video, you heard a conversation between a standard and a custom voice. Standard is offering many different speakers, and it was a really nice compliment to our custom voice. Another really interesting feature we used with this voice is SSML, a markup language allowing you to tweak the pitch, rate, prosody in your lines, giving different flavors to your voices. Let's say if you want to speed or add a break to a line, it's possible with SSML. Another strong advantage of Cloud TTS is that we'll benefit from any update Azure is doing to their voices. So our ITC voices will be able to evolve with Azure. As for the billing, it's made per million characters, and you're able to monitor thanks to the Azure portal. Azure portal is really nice because you can monitor the numbers of calls, the latency of your calls, and errors. And when we shipped Flight Simulator in August, we were able to track errors and adjust our subscription based on the usage we were getting. So if you plan to ship a game with Azure TTS, get in touch with them to adjust your subscription following the usage you'll be getting. 6 months after shipping the game, Azure TTS is still driving our ITC communication in Flight Simulator. On the list of improvements, we of course would like to add more voices for more speaker variety, and we keep an eye on Azure TTS evolution so we can evolve with Azure. Cloud TTS is something promising for simulation and games development. I guess many game studios will be happy to have higher quality and custom-made TTS. I'm pretty sure it will be something massively used by games in the next few years.
So I'd like to thank Aurélien for this great presentation. So as a conclusion, I would say that I think that the cloud in the video game industry has often been seen only as a new way of distributing experiences without dedicated hardware. I hope that this presentation is showing that thanks to Azure, this is way deeper than that. So I've been often asked what was the major change, the major improvement that came with a flight simulator. My answers has always been Azure. So by the past, floppies, DVDs, and Blu-rays had been once after the other some major improvement for the game industry, opening new possibilities for devs and new kind of experiences. So in my opinion, Azure is this ultimate layer of this history, bringing an endless computing power and data distribution. So I would like to sincerely thank you for your attention during this presentation, and I wish you have an excellent GameStack Live. Thank you very much.